Vinny is studying the effect of positive reinforcement for her psychology class. She randomly assigned 6 pigeons to 2 different positive reinforcement schedules. After training the pigeons, she measures the number of correct responses by each in 10 trials. Using a two-tailed test, an alpha level of 0.05, use the data below to determine whether there is a difference between the 2 schedules. Conduct the appropriate t-test and state a conclusion in APA format. Okay. The first step is to read the question and write down important information. Step 1. Step 2. If there is a difference between the 2 schedules, then the null hypothesis will be rejected. The t-test Step 2. If there is a difference between the 2 schedules, then the null hypothesis will be rejected. The t-test value obtained will have to pass the critical value for a two-tailed test at alpha level 0.05. Step 3. Step 3. Write down the values of t that corresponds with the sample info. So in this case, we are conducting a two-tail test with alpha level 0.05. So we will look at the table. We have a total of 16 pigeons and must know our degrees of freedom. Our df is n minus 2, so in this case it is df is equal to n minus 2, which is 16 minus 2, which is equal to 4, which is equal to 14. Step 5. Step 4. Step 4, we will look back at our t-distribution chart, and on the left column, here on the left column, look for the degree of freedom of 14, right there. And on the bottom row is the proportion in two tails combined, right here. We go to 0.05, and df of 14, our critical number is 2.145. So if we get a value greater than this, then we must reject the null hypothesis and conclude that there is a difference between the two schedules. We will use the t-statistic independent measures as the two samples are independent of one another. So our critical value is positive and negative 2.145. Step 5, we will state our null and alternate hypothesis. In this case, our null hypothesis is population of 1 minus population of 2, sample 2, is equal to 0, which means that there's no difference between the population means. Our alternate hypothesis states that there is a mean difference. Step 6. The formula for the t statistic is m1 minus m2 order minus population mean 1 minus population mean 2 over the standard error of m1 minus m2. Step 7, we will set population mean of m1 minus m2 to 0 whenever we work on an independent measures t-test. Because 0 is the only number that we can be sure of for the population mean. Step 8, get your formulas in order. In order to obtain the t-value, we first need to calculate the sum of squares using this formula. Then we will use that to calculate the pool variance We will then use our results from the pool variance to calculate the estimated standard error It's supposed to be separate. Finally, we will take that result and calculate our t-value and see whether or not there is a difference between the two schedules. Remember to equate this to 0. All right. Sample 1, n is equal to 8. Sample 2, n is equal to 8. Our df value is equal to 14. Okay. Calculating the sum of squares for sample 1 and sample 2. You look back at the data, you square each one of these numbers. Then you add them up to get 339 minus, you take all of these numbers, add them up, then square it. You get 51. 51 square gives you 2601. So using the formula, you get 339 minus 2601 over n, which is 8, which will give you 339 minus 325.125, which is equal to 13.875. And you do the same thing to find the sum of squares for the second column, sample 2. When you add all that up, you get 251 minus, add up everything on this side, then square it. You get 43. 43 square is 1849, using the formula over n, which is 8. So you get 251 minus 230.5 Okay, I made a mistake. Over here it's supposed to be 231.125. So 251 minus 231.125 gives you 19.875. So for SS1, we got 13.875. And for SS2, sum of squares 2, we got 19.875. Our next step will be to calculate the variance, the pool variance. The formula for that is SP SS1 plus SS2 over dF1 plus dF2. Our sum of squares 1 is 13.875 plus our sum of squares 2, which is 19.875, over the dF of 1, 7, plus the dF of 2, which is 7, which give us back our 14 that we had earlier for the dF of 14. When we calculate this, we get 33.75 over 14, which gives us 2.4107 for the pool variance. So adding that to our information box, we get 2.4107 for the pool variance. Our next step will now be to calculate the standard error using the formula S. M1 minus M2 is equal to radical SP2 plus SP2 over N1 over N2. In this case, these numbers will be the same, which is 2.4107 over 8 plus 2.4107 over 8, which gives us radical 0.602675, which gives us 0.776. We add that to our information, and we get that this estimated standard error is, I'll put SE for short, 0.776. Finally, with all this, we can calculate our t-value. The formula for the t-value is M1 minus M2 minus 0 over standard error. This is the average of the first sample minus the average of the second sample. So that gives us 6.375 minus 5.375 over 0.776. Since these three numbers are the same here, and this is just a difference of 1, we know that the top value is automatically 1 over 0.776, which gives us 1.288 for our t-value. So the t-value is 1.288. Now to wrap it up, step 9, we state our conclusion. Since the t-value of 1.288 is less than our critical number of 2.145, we cannot reject the null hypothesis and therefore conclude that there is no difference between the two schedules. Writing this in APA format gives us T14, this is your DF here, is equal to 2.145. This is a critical number. Over 0.05. The two-tail test for 0.05. A by two-tail here. Thank you.